Hello, this is Mr. Stansbury. I'm going to take you through the notes on arithmetic series. At the end of this, you should be able to say I can find the sum of an arithmetic sequence, the formula for an arithmetic series, or the number of terms in the arithmetic series given terms of the sequence. Okay, so let's talk about what arithmetic series is. It's the sum of the terms of an arithmetic sequence. Okay? Now, the sum of a finite, meaning ending, arithmetic series is if the first term is u sub 1 and the last term is u sub n, and the common difference is d, then the terms are going to be u sub 1. And then to get to the second term, you take the first term and add the difference. To get to the third term, you take the first term and add the difference 2 times, so forth and so on. And then the last term is going to be u sub n. To get to the term right before that, it's going to be u sub n minus one of the differences because it's right before we get to the end. And then to get to the one before that, it would be the last term minus 2 differences, so forth and so on. Okay? So the sum, S of n, would be all of these terms here added together. Okay? And then reversing those, writing them in the backwards order, just like we did in the last lesson that we did, would look like this. And then when we add all these together here, u sub 1 plus u sub n, u sub 1 plus u sub n, and we have a positive d and a negative d, so that's still going to be u sub 1 plus u sub n, u sub 1. We got the 2d and the negative 2d cancel out, so it's still u sub 1 plus u sub n. All of these are going to be u sub 1 plus u sub n, okay? Now, these are two terms added together, so that's why this is twice the sum, because there's two of these things added together is going to be u sub 1 plus u sub n, and there's going to be n number of these different terms here, right? Because this is officially the first term, second term, third term, so forth and so on, all the way up to the u sub n, which is the last term. Okay? Now, with that, we can take, so we've got 2 s of n is going to be n times all of these, right? Because there's n number of these. So like, let's say if there were 7 of these, it would be 7 times u sub n plus u sub n. So there's our, we don't know how many there are, so we leave the n in there instead of the 7. So it's n times u sub 1 plus u sub n. Okay? And since there's 2 of them, we would divide both sides by 2. So we basically take this whole thing divided by 2, or just write it as n over 2 times u sub 1 plus u sub n. Okay? So that's this is how we find the sum of our arithmetic series. Okay? Now also with that, from earlier, we already knew that u sub n is u sub 1 plus n minus 1 all times d. So this here is the same thing as this u sub n. So we're basically just taking this information here. Let's do this. So we're taking this here, and we're basically substituting it in for that. So if you'll notice, we have all of this right here, plus, now instead of the u sub n, it's all of this. So this basically is going right there. So u sub 1 plus n minus 1 all times d. That's this formula here. We go through and we simplify this. Basically, is u sub 1 plus u sub 1 is 2 u sub 1s. And we come up with the formula for the sum of an arithmetic series. Okay? So that's the sum of all the terms is our arithmetic series. All right? So let's try an example with this. Okay, so example 25. Find the sum of 2 plus 7 plus da, 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 all the way up to 40 different terms. Okay, so we've got the two formulas that we had from the page before. Okay, so if we know the last term, we want to plug that in right there for u sub n. That's our last term, first term, last term. If we don't know our last term, we usually want to use this one over here. So let's try this s of n here. So we got s of n is going to equal, n is the number of terms, and they tell us that it's 40. So we do 40 over 2 times 2 times u sub 1, which is the first term, which is that 2 right here, plus, again, n is number of terms, plus 40 minus 1 all times the common difference. So what are we adding each time? Plus 5, plus 5, plus 5. So 5 is our common difference. And then all we want to do is just simplify this thing here, and that'll tell us what the sum of this entire series is, all the way up to 40 total terms. So this is going to be 20. So S of n, officially n is 40, right? So this is saying the sum of the first 40 terms is going to be 20 times, that's going to be 4, plus 39 times 5, right? So let's just bust our calculator out here, have them help us out. Let's see, 20 times 4 plus 39 times 5, right? Right. And we get 3980. So the sum of the first 40 terms is 3,980. Right? Did I get that number right? 3980. Yep. Okay. Okay. Before we take a look at the next example, let's take a little comedy clip break.
My wife has instituted this open door policy where if one of our kids has a nightmare, they're welcome to come in our room and pee in our bed. Luckily, that only happens every night. You ever slept next to someone that's wet the bed? Delicious. You're asleep, right? So when you wake up, your first thought is, oh my God, I wet the bed. Then your next thought is, it's not that wet. I'll just scoot over a little bit. If I pretend to be asleep, maybe she'll deal with it. Oh, I didn't even notice. Hey, while you're up, can you make me a sandwich? Thanks, honey.
All right. Example 26. Find the sum of all these terms here. So it doesn't tell us how many terms there are, but it does tell us that the last term is negative 116. So we know the first term and we know the last term. So we usually want to use this. Now, there's one small problem. We do not know the n, the number of terms. So we're going to have to figure out what the number of terms is, and here's how we're going to do that. We're going to use the u sub n formula, right? Is u sub n is u sub 1 plus n minus 1 times d, and that we'll be able to figure out what the n is for that. Okay, so u sub n, the first term is 31 plus, we don't know the number of terms, n minus 1, and then the common difference. So it looks like we're subtracting 3. We're subtracting 3 each time, so we got that is a negative 3. So we got u sub n is 31 plus negative 3 times n is negative 3n. Negative 3 times negative 1 is plus 3. So our u sub n is negative 3n. 31 plus 3 is plus 34. Okay, now, we know that our last term is negative 116. So what we're going to do is we're going to plug negative 116, whoops, missed a 1, in for our u sub n, because that's our last term. And then from that, we can figure out what our last term is, how many terms we have, right? So subtract 34 from both sides. And we get negative 150 equals negative 3n. Divide by negative 3, and we get that n is going to be, what, 50. So that means that there are 50 total terms in this. So now we know our n. Now we can plug that in and use this first formula here. So we have S of n equals n we now know is 50 over 2 times u sub 1, which is 31, plus the last term, which is negative 116. Okay, so we've got S of n, and really, sorry, I should be putting in 50. So the sum of the first 50 terms is going to be 25 times 31 minus 116, which is going to be what? I believe that's, negative 85. Yep. Okay, and then so now we just got to figure out what 25 times negative 85 is. So 25 times negative 85 gives us negative 2125. Okay, so the sum of so if we add the first 50 terms together, we're going to get negative 2125. And some people are saying, wait, we started with positive numbers. But if you look, eventually this is going to turn into negative numbers, and all these negative numbers are going to far outweigh all these positive numbers. So that's why the sum is going to be a negative number. Okay? All right, one last quick example here. Example 27. Arithmetic sequence has a first term of negative 5, common difference of 2.5, and the sum of the terms of the sequence is 130. Find the number of terms in the sequence. So these two formulas we have to choose from. Here's the thing that I see. We've got 2.5 is our 2.5 is our common difference. So that's going to have to go there. There's no spot for it in there. So let's use this formula here. We know that the sum of the sequence is 130. So that's our S of n. So we got 130 equals, we don't know the number of terms, n over 2. We know that this is twice the first term, and the first term is negative 5 plus n, which we don't know, all times d, which is 2.5. So let's see if we can solve this thing here, right? 130 equals n over 2 times negative 10. Let's see, 2.5 times n is plus 2.5n, and 2.5 times negative 1 is negative 2.5. So we get 130 is n over 2 times negative 10, and negative 2.5 is negative 12.5 plus 2.5n, right? Now, thing that we want to do here is we want to get rid of, I don't like this 2 right here. So if we multiply both sides by 2, that'll get rid of that, right? So that's going to be 260 equals this 2 and this 2 are going to cancel each other out. N times negative 12.5 plus 2.5n, right? So now we distribute that through. 260 is negative 12.5n plus 2.5n squared, right? Okay, so let's see if we can't get rid of this. Let's see these 2.5s. Maybe let's move this 260 over first, because we want to set one side equal to 0. So subtract 260 from both sides, and then let's also write this in the proper order. So we'll put 2.5n squared first minus 12.5n minus 260. Okay, we should be able to divide everything, I'm hoping, by 2.5. All right, so we get 0 equals, that's going to be n squared, and then that's going to be minus 5. And then if we take negative 260 divided by 2.5, we get negative 104. So that's 5n minus 104. So then now we need to factor this to figure out what our n's could be. N and n. Factors on 104 that have a difference of 5. We're just going to have to start guessing and figure stuff out. I'm going to write these down for you. Okay, so here's all of our factors. The ones that have a difference of 5 are 8 and 13. So we got 8, 13. These have to add up to negative 5. So negative 13 plus 8 gives us our negative 5. So that means, n has to equal negative 8, because negative 8 plus 8 is 0, or positive 13. 13 minus 13 is 0. Now, negative 8 terms does not make sense, so that means there has to be 13 total terms in the sequence. Okay? All right. We made it through. If you have any further questions on this at all, please feel free to ask in class. Thanks.